All right, so we're going to start with part A, where we want to write the vector 0, 1 as a linear combination of the vector -1, 2 and 2, 3. So when we want to write something as a linear combination, basically we want to find the vector x1, x2 such that when I set up the equation like this, basically this is equivalent to taking the matrix made up of the two vectors here, multiplying it by the vector x1, x2, and saying that that has to equal my desired vector, which is 0, 1. And so basically, this expression right here is also equivalent to the augmented matrix, -1, 2, 2, -3, 0, 1. So I'm going to be working with this augmented matrix, and I'm going to try and get it into reduced row echelon form. And when I get that, that's going to give me my solution for x1 and x2. Just as a reminder, this first column represents the x1 variable, the second column represents the x2 variable, and this last column is representing, like b or some other vector. So when we actually reduce this all the way down to reduced row echelon form, we get the following matrix. So therefore, this means that x1 equals 2 and x2 equals 1. So linear transformation here, then I can basically go like that. Let me do it in red so we can see that that's our final answer. And just to do a quick little check, I'm going to see if indeed, if I multiply each of these vectors by their coefficients and then add them up, if I actually do get 0, 1. -2 plus 2 equals 0, and 4 plus -3 equals 1. And so I see that that does check out. So for part B, some things to keep in mind is that a transformation is basically multiplying a vector by a matrix to get a new vector. So usually a transformation of vector x is taking matrix A and then multiplying it by vector x. So if I'm saying that I know that t of, what is it, -1, 2 equals -1/8, what I'm saying is I know there's some matrix A that I can multiply -1, 2 by to get -1, 8, to get this vector. Now, if I look here, this is 1, 2, 3, 4 unknowns. And if I do this multiplication, I'm actually only going to get 2 equations, and so then that's not enough. But let's actually look at what this multiplication would entail. So if I multiply, to multiply vectors, you do a11 times x1 plus a12 plus x2. Basically, this is what this matrix equation is telling me. I can multiply this left-hand side and then set my result equal to the right-hand side of the equal sign. I can do the same thing for the bottom row. So I have -a21 plus 2a22 equals 8. So again, this is not enough, these are not enough equations for the amount of unknowns. So luckily, they gave us another set. So the important thing with transformations is that it is the exact same matrix A that we're multiplying by each of these vectors to transform them. So I'm able to say that, okay, this is going to be a11, a12, a21, a22, and then I'm going to multiply that by 2, -3, and then that's going to give me 2, -13. When I combine it with the previous transformation, I now will have 4 equations and 4 unknowns. So that's going to allow me to find the set of solutions to satisfy that system. So then we now have a system of 4 equations. And what we can do is we can set up a matrix with these 4 equations to find the solution set for A11, A12, A21, A22. When we find that solution set, that's going to tell us what this matrix A is that I can then perform the transformation. So the first equation here then would be like -1, 2, 0, 0, and then -1. I'm going to just go straight to the augmented matrix. And again, what we can do is we can just plug this puppy into Octave and get the reduced row echelon form. So the reason why we want to go for reduced row echelon is because that is going to give us our solution set. And because we have 4 equations for 4 unknowns, we should be able to get one unique solution. So when we do this, we get A11 is 1, A12 is 0, A21 is -2, and then A22 is 3. So what that tells us that our matrix A for this transformation is 1, 0, -2, 3. Okay, and again, I always like to just double check that things are what they say they are. So what this means is when I do my transformation of -1, 2, and I'm really hoping I get -1, 8, but we'll see when we do this multiplication. So when I do the multiplication, I get -1 plus 0, and then I get 2 plus 6, and that does indeed give me -1 over 8. Yay. And then if I do my transformation of 2, -3, I take the same matrix A and I multiply that by 2, -3. And I'm hoping to get 2, -13. So let's see. 1 times 2 is 2 plus 0. And then that's going to be -4 plus -9. And that does indeed give me 2, -13. Okay, so we know that we have the proper matrix. And now what we can do is we can find our transformations of 1, 0, or I'm sorry, not 1, 0, 1, 0, and transformation of 0, 1. So to do the transformation of the vector 1, 0, what that means is we're going to take our vector, we're going to take our matrix A and multiply it by the vector. So we're going to go 1, 0, -2, 3, 1, 0. And then that's going to give me, I'll do it in this color, 1 plus 0 minus 2 plus 0. And then that's going to give me the vector 1, -2. Then if I do the transformation of 0, 1, I take the same matrix A, because that's the whole point of a transformation. You're applying the same matrix to any vector in the proper vector space. And so then that's going to be 0 plus 0 times 0 plus 3. And that's going to give me 0, 3.